The goals of this lab was to compare the actual motion to the predicted motion with GlowScript and plot the energy changes that occurred in the system with the for the predicted motions. Our findings: the predicted motion and observed motion are similar in the x and y axis with greater similarities in the x axis. The change in total energy is zero. The changes in the other energies reflect this finding. The key concept for this lab is Newton's second law, which states that momentum is divided by time is equal to F net, which is used to get the velocity update formula, which is also used to get the position update formula. The concept in this lab is the energy principle, which states that the change in energy of a system is equal to the work done on the system plus the exchange of thermal energy. That is the equation below. A system should be defined when dealing with energies. The object in the system impact what types of energies are present and what work is done by the surroundings. For a system with multiple interacting objects, there is a possibility for the following energies in the system: translational energy, kinetic energy, gravitational potential energy, and spring potential energy. There are also other energies possible. The systems in this experiment are the Earth, the spring, and the mass. The surroundings are nothing that includes work on the system. If we set the system to include all elements that do work on the system, then nothing in the surroundings does work. Therefore, work equals zero, which means the change in energy in the system is equal to zero. Since there are multiple objects in the system, we have to consider the potential energy due to Earth and the spring potential energy. In the free body diagram, we had the static equilibrium position, where the force of the spring and the force of the gravity are equal to each other. On this slide, we tracked the object on the end of the spring. The tracker gave us the x and y coordinates of the object, and we took those coordinates and took it into an Excel file and then converted the Excel file into a CSV file. This slide we have the graphs made by tracker, and we have the object's mass and when we started the observation and when we ended it. These are the initial conditions for the glow script, and we took these conditions from the video before, such as the ball's mass and the position vector. This slide we have the interaction constants, including gravity and the K for the spring. The spring constant can be derived from the oscillation period of our spring using the formulas below. Equations for this lab are the distance from the relaxed spring, energies involved, and net force velocity update and position update. And below are the equations, and at the bottom are the necessary code needed for those equations. This slide includes all the code and some of the formulas used. The video showing the results of the code, and they are meant to mimic the oscillation of the original video. This slide we have the model versus the experiment. So on the left and center we have x position versus time and y position, and then on the right we have the average change in energy, which is 0. The change in gravitational potential energy and the change in spring potential energy in green are opposite and oscillate. The x position versus time graph shows that the model is accurate in predicting the x position, while the y position is a little bit less accurate. The potential sources of error are not accounting for other forces such as drag, not accounting for other energies such as thermal or rotational, and not consistently marking the center of mass of the object using tracker analysis. Energy principle satisfied. Yes. Using the change in energy versus time graph, the sum of the change in kinetic energy and the change in gravitational energy and the change of spring potential energy equals 0. The total energy, which is the orange line in this graph. The total energy equals 0 because the spring's potential energy is opposite in sign to the gravitational potential energy. And below we have the formula for that. Time period between two crests or two different troughs in the position versus time graph and tracker is equal to the time to complete one cycle. The average oscillation period can be determined by finding the average of 3 cycles. As you can see, there's a difference between the x and y of about 0.157 seconds. The difference between the oscillation has an impact on calculations of spring force and the spring potential energy. This can be caused from drag force, incorrect tracking, or camera distortion.